Thank you for coming out. So my name's Charles Feddersen. I'm a program manager on the Synapse engineering team based out of Redmond. So it's nice to be in this part of the world. What I wanted to do today is talk a little bit about how you should think about Synapse with respect to the capabilities it has and how you would think of it relative to existing Azure services. What I then want to get into is work through just some of the basic concepts and explain to you just some of the really high-level concepts. And then this morning, actually, then we'll sort of go right down into the weeds. And this morning in the keynote, Rohan talked a little bit about some of the secret sauce and the magic within Synapse that enables the scale that we've demonstrated. That execution of that benchmark at petabyte scale is unheard of scale. And so what I was actually going to do is drill into the weeds and show you a little bit of how we built the distributed query optimizer or the distributed query processor, so you can see some of the considerations we need to make when we're operating over data at that scale. And because we're operating over data at scale, the number of machines that need to operate at that scale as well. So it'll be a bit of a split level session, but I want to try and hit some core concepts. So let's get moving. And we've got a very low projector, so I'm going to stand on one side or the other. So you will have seen, or you may have seen images that look like this that talk about the modern data warehouse. And the way that we think about modern data warehousing is very similar to how you would have thought about traditional data warehousing. There's a notion of ingesting, there's a notion of transformation, and then modeling and serving out the end. And what we discovered, and we kind of sort of knew this, and what we reinforced though by speaking to customers, is these same Azure services for doing data ingestion, data lake storage, big data processing, and SQL relational serving were not only commonly used, but were commonly stitched in exactly the same way. And so while we believed and while we think the cloud has done an exceptional job of accelerating time to provision, you can all walk up to any cloud vendor and provision a new service in a matter of minutes, the promise of time to solution hadn't really held true. And so we took a step back and we wanted to see if we could help customers not just deploy faster, but build and productionize faster and realize that value. And so this really turns into Azure Synapse. We take these core capabilities and we fold them into a single, fully integrated service. And what we showed this morning in the keynote is how I could go all the way from right-clicking a file and sampling that data to running complex queries at petabyte scale, putting ML into that project without any coding at all, and then surfacing it through Power BI. Now I did pre-code some of it to accelerate the demo, but you certainly sort of would acknowledge that there wasn't just vast pages that I scrolled of code. It's very, very lightweight. And so if we keep moving, and if you've been past the booth today, you will have seen the slide that looks like this. This really explains what is in Synapse. Foundationally, we depend on Azure Data Lake storage for our storage layer. That's not part of the service itself, but it's a mandatory component when you provision a new instance of Synapse. Then what we went and did is we created commonality for all of the management, security, monitoring, and metastore in Synapse. Many of you who have developed on maybe big data systems and tried to then take it to SQL systems will have taken your Hive DDL and you will have cut and pasted it into SQL or other relational platform, and you're trying to keep all of this data in sync. Synapse handles that for you. You can open a notebook experience in Spark, you can write 3 pages of Python, and at the bottom of that you can write save to table. And what that does is it dumps a whole lot of Parquet onto the data lake, and it creates a table structure. We will automatically synchronize that into the SQL environment so that your analysts who start writing SQL will see it, and they're immediately productive without needing to build pipelines between systems. And we did some very interesting work on the Parquet format in SQL, which I'll talk about shortly. Then we bring data integration into the play. So many people here will have built ETL pipelines, I'm sure. The requirement of centralizing data to do analytics because it's coming from disparate systems and we want to join it together. And this is what gives you the SQL experience, the notebook, the data integration, plus the management and monitoring all in a fully unified experience. Now the important thing to note about Synapse is it is not a walled garden. With Synapse, this box represents a single service, but if you've used some of our partners, if you build on things like Informatica or Tunity or Talend, if you use MicroStrategy for your reporting, everything just works. We took the common components and we put them into a single integrated solution, but everything else that you've known historically to work with the Microsoft ecosystem absolutely still works with Synapse. So let me start to pick through some of these components here. I'm going to skip that one in the interest of time, we're a bit late. like I mentioned, the studio is completely web-based. If you're a SQL person and you like to sit in Management Studio or Visual Studio or Azure Data Studio, that all works as well. You still give it a server name, you still give it your credentials, and you can log in. What the Data Hub does is gives you access to all of your data, regardless of whether it's your storage accounts, which I touched this morning, your enterprise data warehouse and all of the tables within it, and even data sets that belong to Power BI. And so you can see here how, again, we're bringing all of your data assets, not just into one service, but into one visual experience, which enables you to move around very, very quickly. With SQL Analytics, you can see here, and I talked about this morning, you can deploy multiple SQL compute pools to operate over your data. This morning we talked about creating them for different teams within your organization. Engineering could have dedicated compute, and they will operate on that compute. Finance and marketing could have other compute. These clusters are fully elastic. You can scale them up and scale them down completely online. You can pause or resume them whenever you feel like it. Or you could also switch to SQL on demand, and that's on a pay-per-query basis. The other thing actually that I was touched on for SQL, not obvious in the screenshot, we've also enabled full IntelliSense as well. So as you type your SQL, the little drop-downs appear, and you can auto-complete on those terms, which we hadn't done in a web experience. Previously, it had been limited to the thick client. This is what the notebook experience in Spark looks like. So this morning in the keynote, had I clicked on Open in Notebook, this is the experience I would have launched. Here's the Spark pool that I'm running. You can have multiple Spark pools. The same properties apply. They're fully elastic. You can scale them up and scale them down. You can pause them. And so this looks like we're writing, I'm going to say that's Python. This is where we get to some interesting capabilities for building pipelines. So in the Synapse portal, you have a completely code-free data flow, and that's what this represents. Think of it as declarative. You're basically saying, this is how I want my data to flow, and we will generate the code for you and deploy that on Spark clusters for transformation at scale. One of the limitations that existed traditionally with ETL was it was kind of scoped to one machine, unless you wanted to push it down to distributed warehouses on premises. With Synapse, all of your ETL is fully distributed. So we think of this as not only being code-free, but very scalable depending on the volume of data that you want to transform. What we actually do in addition to code-free data flows is also have what we call code-free data wrangling. This is an Excel-like experience. And you can put the wrangling component into the data flow, and when you open it, it will show you the data in its shape that it exists at that point in the flow. And then what you can do is go Excel on it, and change it. It's a right-click heavy experience to split, merge, filter, do whatever. You'll see a sequence of steps appear down the right-hand side of all of the changes you've made. You can back out of them as well. And then when you're done, you just hit save, and we will code gen all of those transformations under the covers as well. And you've basically just Excelized your data flow rather than needing to code it or build a whole lot of transformation. We also have this notion of linked service. And so here you can see the demo that I gave this morning with Power BI was using Power BI as a linked service into the Synapse experience. And that's what enabled me to also publish it to Power BI. But you can see our linked services extend not just to visualization and Power BI, but also to all of the connectors that we have for our pipeline. So you can see there's a few examples here for there's SAP, there's Postgres. And one of the things I didn't mention is we offer fully secure hybrid throughput, and we have sustained throughput through a hybrid connection of up to 2 gigabytes a second, so long as your network can support that. So not many people move 2 gigabytes or even 10 or 20 gigabytes a day, but the fact that we can push at such high throughput means you can shorten that time in your ETL load and you're not bottlenecked by the system. With respect to the management hub, there's not a whole lot to see here, and the text is very small, sorry. But what these are is my data warehouse. Here's my Power BI. It's basically just a centralized place to manage all of these capabilities within Synapse. And so today you'll think about Azure as being the Azure portal as being a very centralized environment for managing all of your cloud services. But we're data people. I think everyone here is a data people. We don't really care about what someone's VM is doing and all of that stuff. And so when you bring this into the Synapse portal, it's completely focused on your data solution and all of both the linked services and the embedded services that you have there. And then finally, for monitoring, pipeline is really where you do the most of the monitoring. So it's a single interface. You can look at job run times or query statistics for the warehouse. You can look at job statistics for Spark. You can look at the pipelines as well. See if your pipelines are running, if there's any latency there. It really ties the full ecosystem together. So I moved very, very quickly through that because I have a lot of slides and not much time. I really wanted to hit on some of these core components of Synapse and how they all fold together into a single service. So if you think about Synapse with respect to connected services, this morning we did actually show Power BI and Azure Machine Learning. The connected service concept is key here. So within Synapse, you can think about that data integration, SQL and Spark, but then that connected service, which is that link service that I showed you, and then our full partner ecosystem, of course, just continues to work. And what Rohan touched on as well was Azure Data Share. One of the really sort of interesting things about Data Share is it makes no assumption of the compute engine that is running. You can share any data with anyone using Azure Data Share. You may have a whole bunch of Parquet that you're running SQL over, and a consumer might want to run Spark, Databricks, or what have you over it. Because we share at the data level, you can bring any engine to that data. We're not saying, I'm sharing warehouse data, and so you can only consume it with a warehouse. We don't make that assumption or that constraint on the sharing model. So you will have seen these charts. Today, Rohan showed this one, TPCH. The interesting thing is that Synapse also is the price performance leader for DS as well. These are the two. They're very distinctly different benchmarks, and actually normally one platform is better at one than the other. They represent in totality 125 queries, 22 and 103 at the bottom. And so I think it's we think it's a great representation that most of your workloads will fall somewhere within the dynamics of these types of queries. And so you should have a lot of confidence that running your data warehouse on Synapse is going to be very, very performant at a suitable price point, given the statistics that were published. And this was in January, and the bottom one was in March this year. With respect to security, we invest very, very heavily in security. Everyone wants to do self-service BI, as opposed to monolithic BI tools that we may have used in the past. When you get to self-service BI, we think, Microsoft thinks about Power BI, but there are a lot of other tools out there, and most of your companies will probably use many of these tools. You may even have developers that you encourage to build their own custom apps. And at the point that you have a lot of applications accessing a central repository, you can no longer do application level security on the data. You must put all security in the platform itself, because the one common thing that everyone has is their login. Everyone should have one login. And so a few call outs here. In Synapse, we provide native row level, column level security, and dynamic data masking. This means that if I have the typical example I give is the United States with 50 states. If I have a table that has data for all 50 states, and row level security is a policy where I can only access Washington State, I'll walk up and hit select star, and I'll only get Washington. And the guy from Oregon will only see Oregon. And at that point, it doesn't matter where you're coming from, what application, however you got there, because it's all based on your login. And so that's a very key capability. And when you bring column level security into it, that effectively enables cell level security on any table of any scale within Synapse. When you hit a column level security limit, like you're not allowed to hit it, you actually get an error message. And so that error message means you're not getting a result set back, which is good, but it means that you may have access to some of the data you asked for. Dynamic data masking is really powerful then, because what that will do is it could take an email address, for example, and some people can see the email address, I don't know who they are, but when I run it, I'm going to get 4 or 5 X's back. So I can't see it, it masks at runtime, again, based on my identity. But the important thing is I get a result set back. So if I've asked for a report, I'll get the proper table back, it'll populate in my report correctly, and I just can't see the data that I don't want. So these two are very complementary of each other, and we see customers leveraging all three of these in combination very frequently, particularly for enabling self-service BI at scale. One thing we didn't talk about this morning is what we've done with Parquet. So we've built something that we call Parquet Direct, which effectively, and we have a blog about this, by the way, if you'd like to read more, we enabled Parquet as a first-class citizen in the SQL engine itself. So what this shows, the black columns, which you probably can see, is our performance at querying directly over Parquet in the previous version of Data Warehouse. And we didn't do any caching, and we didn't have a whole lot of optimization for the Parquet type. What we did with Parquet Direct by embedding it directly in the engine is so far we've enabled 13x performance improvement over the previous version, and we've got some more optimizations that we're going to continue to burn in. So why is this really important? At the top of the session, I talked about that ability for the data scientist and the analyst to work together. The data scientist can produce something on Spark, and that will produce Parquet typically, and then the SQL analyst wants to query the warehouse. Synchronizing the meta store is one part of the problem, but if the SQL analyst has got absolutely no performance because we're querying off the lake and we're not bringing a whole lot of columnar optimizations to the engine, then it's just going to be a bad experience. Then they need to load it into fully managed tables, and that creates a hop. So with this, what we're effectively enabling is in-memory caching of the Parquet file format directly off the data lake, that you'll potentially be able to drive interactive dashboards directly off Parquet in the data lake that was maybe born into that environment from Spark only a couple of minutes earlier. And this is one of the capabilities that really breaks down some of those operationalization barriers between the SQL analyst and their BI tools and the really high value predictions that the data scientists are producing in Spark. So now let me dig in, I'll pivot here and get onto the query engine that we talked about this morning. So a couple of years ago, we saw this challenge coming of really running large scale analytics in the cloud. And when you start to, many of you will have run servers and you may have even racked servers. Normally one server, you put it in, it'll run for 3 or 5 years and you won't have too many issues, generally speaking. When you start to run queries across very large clusters, you need to expect that things are going to fail. We also know that with the cloud, we have amazing elasticity, right? When I was working on appliance-based systems, the fact that I could roll a rack in and scale the appliance like that was the most phenomenal elasticity ever. But you'd maybe do it once or twice in hardware life. In the cloud, you can scale up and down multiple times a day to suit your workload. And so we needed a distributed SQL engine that was really hyper-elastic and just built completely cloud native. And so if I give a few examples here, let me walk you through what's on the slide, and I'm going to show you some scenarios that this engine is built to address in the cloud. What this basically represents is a compute cluster with 4 nodes. Each circle is a compute node, and I've issued a query, and the optimizer has decided that there are 16 tasks that I need to go execute. And so each of these triangles is a little task, and it's very simple. We've got 4 nodes, we've got 16 things to do, so we're just going to balance that out nice and evenly. So what we can do then, of course, is scale. And so what we can actually do while we're running queries is just reschedule tasks across the remaining nodes in both directions. And so sometimes you'll find your workloads are going a little bit slow, you want to dial it up. Separation of compute and storage completely enables that. All of the smarts are in the query processor to be able to reschedule those tasks onto the new cluster you have, or we think of it really as changing the cluster topology. So this one's a pretty basic one. Let me talk about actual fault tolerance. Sometimes things fail. And sometimes we can't get a node immediately, but we want your workload to keep running. We don't want you to wait while we're pulling nodes, while we're finding nodes to go reissue queries on. So what we can actually do is reschedule. We have awareness that you still have these healthy nodes, and we will reschedule your work just across those compute nodes. And then at some point when we bring another node in, it could be really quick, could be a little longer, never really know, we will just rebalance that onto that node as well. So that's another interesting scenario to make sure that all your queries continue to run successfully, everyone has a great experience, regardless of any failures that might be happening on hardware. This one actually starts to get really interesting. When you get into distributed systems, you run a risk that the whole system gets throttled because one node is running really hot. And sometimes your data might be skewed, generally not. More often it's a byproduct that I'm running queries, and actually this node just needed to read more data. And I needed to spend more compute cycles on the data. And so this one's running at 100%, and maybe the others are only running at 50%. This is where you can start to do some really, really clever things. So with Synapse, we will detect this, and we will automatically disaggregate this onto your remaining nodes. And so we'll get more utilization out of the underutilized nodes. We'll pare down the utilization of the busy node. And so now what we're really trying to do is bring intelligence to the platform that you're getting the biggest bang for your buck at all times. And sometimes you can have a scenario of sustained hotspots. Maybe this one is still running hot. Those 2 tasks really need a lot of data, and we want to break it apart even further. Maybe we actually over-allocated here. Generally not, we're pretty conservative. And so what we can do in a very granular manner is just add one more node. We're not doubling and then doubling again. Very, very granular control of the compute capacity just to try and basically lift all boats at once and make sure that all of these nodes are running in a very, very efficient manner. And so you can, if you think back to where we started this diagram, I had 4 nodes and I had 16 tasks and they were beautifully balanced. But you can see how situation changes, as the platform will respond. The goal is to maximize, the basic design principle is to maximize the throughput of your workloads on the Synapse platform. And then of course this may still not be enough, and we can continue to scale in the same promise of that first example that I gave. So this is pretty much everything that I had except for this slide, and I want to re-emphasize this. This is the technology, as Rohan mentioned this morning, that enabled us to go and run the full 22 queries of TPCH at a scale of 1 petabyte. The currently documented highest one is 30 terabytes. So this is not a 10 or 20% incremental improvement. This is a sizable step up. The largest table in this has 6 trillion rows, and there are some queries where it joins upon itself. So this is a massive workload of very complex and intentionally designed queries to really stress the system in different dimensions. And we're really proud of the fact that we've been able to run this at petabyte scale, and we're very confident that hopefully any workload that you would bring to Synapse and try to run, the platform is going to stand up both with respect to the scale that you want to run, but also, as we just described in the new distributed query processor, the reliability of the platform as well, given some of the complexities and challenges of operating at so much scale. So that's everything that I had. I'd like to thank you for your time. I think we're right on time as well. And I hope everyone enjoys the rest of the conference. Thank you very much.